Hi guys, welcome to this UKMT Senior Maths Challenge video. Today we'll be looking at questions 11 to 20 of the 2017 paper. So, question 11. The teenagers Sam and Joe notice the following facts about their ages. The difference between the squares of their ages is 4 times the sum of their ages. The sum of their ages is 8 times the difference between their ages. What is the age of the older of the two? So we've got A is 15, B is 16, C is 17, D is 18, and E is 19. What would we do for this question? Let's make Sam's age X years old, and let's make Joe's age Y years old. And the first statement says the difference between the squares of their ages is 4 times the sum of their age. Okay, so what that means is their ages squared, so X squared minus Y squared, the difference between the square of their ages, is equal to 4 times the sum of their ages, so 4 times X plus Y. So we can simplify this slightly, so we get X squared minus Y squared equals 4X plus 4Y. Second statement says the sum of their ages is 8 times the difference between their ages. So sum of their ages is going to be X plus Y to 8 times the difference of their ages. So it's going to be 8 times X minus Y. So it's going to be X plus Y equals 8X minus 8Y. This is our first equation. This is our second equation. So you can see we've basically got two different equations which make up a pair of simultaneous equations. We can simplify the second equation a bit more. So if we bring the 8y over to the left hand side, we can get 9y. And if we bring the x over to the right hand side, we'll get 7x. Okay, so we've got 9y equals 7x. So could simplify this to y equals 7/9 of x. So we get x squared minus 7/9 of x all squared is equal to 4x plus 4 times 7/9 of x. So that's x squared minus 49 over 81x squared equals 4x plus 28 over 9x. And you know that this is going to simplify to 32 over 81x squared. We need to have a denominator of 9, so if we multiply top and bottom of 4x by 9, we're going to get 36x over 9 plus 28 over 9x over 81x squared, and that is going to leave us with 64 over 9x. And of course what's going to happen here is these are going to simplify. So we're going to have 32 over 81. We're going to have an x which cancels out. So it's going to be x equals 64 over 9. Now we can do some simplifying here. We can sort of move terms from both the left hand side and the right hand side. So what I'm kind of thinking is we could bring this 9 over to the left hand side, so you could multiply both sides by 9. And of course 9 over 81 is going to be 1 over 9. So you're going to get 32x over 9 equals 64. And then you could divide both sides by 32 and get x over 9 equals 2. And now you just need to multiply both sides by 9. So you get x equals 18. So we've got a value for x, and now we need to find a value for y. Well, that's easy because we made the equation up here that y equals 7/9 of x. We put y equals 7/9 of 18. Well, 18 divided by 9 is 2. 7 times 2 is 14. So that means that Sam, because Sam is x, is 18 and Joe is 14. And the question said, what is the age of the older of the two? That's Sam. The answer is 18. That is D. So therefore, our answer is D. Okay, question 12. The diagram shows a square and a regular decagon that share an edge. One side of the square is extended to meet an extended side of the decagon. what is the value of x? Got answers of A is 15, B is 18, C is 21, D is 24, and E is 27. So a decagon is a 10-sided shape. And what I thought about this is the sum of all the exterior angles have to add up to 360 degrees. So what we can say, because there's 10 sides, we can say that each exterior angle is going to be equal to 360 degrees divided by 10, which is 36 degrees. So if I show you what this looks like on the diagram, this angle will be 36, that angle will be 36, and also this angle will be 36. So what that means is the interior angles must be 180 degrees minus the exterior angle. Equals 180 minus 36, which is 144 degrees. So we can say that's 144 degrees. So that's 144 degrees. So that's 144 degrees. Now, the other information we've got is we know that this square obviously has interior angles of 90 degrees. So the way I thought about it, this whole shape here, if I go around the outside and highlight it, has 4 sides, which means it is a quadrilateral. And the sum of the angles within a quadrilateral add up to 360 degrees. So I thought, well, we know this angle's x, that angle's 90 degrees. We don't know what this angle is, but we can work it out because we know that the exterior angle there is 144 degrees. So this angle here, let's say I'll call it y. Y degrees is equal to 360. Take away 144, which is 216. So we know that's 216 and we know that's 36. So now we can generate an equation taking the total of all these angles and making them equal to 360. So we have x plus 90 plus 216 plus 36 equals 360. This simplifies to x plus 342 equal to 360, and therefore that makes x equal to 18, which is answer B. Therefore our answer equals B. Question 13. This question is more of a riddle. It says that Isabel says that Josh is innocent, Jennerton says that Tegan is guilty, Josh says that Jennerton is guilty, Tegan says that Isabel is innocent, and we're told that only the guilty person is lying, all the others are telling the truth, who is guilty. So we've got answers as A is Isabel, B is Josh, C is Jennerton, D is Tegan, or E, we need more information. So let's have a look at each person individually. So let's start off with Isabel. Isabel is innocent according to Tegan. So that's good, because no one has said that she's guilty. Let's have a look at Jennerton. Now, Jennerton is guilty according to Josh. But of course, Josh or Tegan may be lying, so we don't truly know, but someone has said that he is guilty. And then Josh has been said to be innocent by Isabel. And then the last person is Tegan, who is said to be guilty by Jennerton. So, let's think about Isabel. Now, no one has said that she's guilty, and Tegan has said that she's innocent. So therefore, let's make the assumption that Isabel is innocent and she is telling the truth, on the basis that no one has said that she's guilty. I mean, Tegan could be lying, and we may find out that she is guilty, but let's just make the assumption that Isabel is innocent. Okay, so on that basis, we can then see what Isabel has said. So she has said that Josh is innocent. If Josh is innocent, he is also telling the truth, which could be the case. But I also think Josh is innocent because no one else has said that he's lying. I mean, again, we could find out that Isabel is lying, but we've made the assumption that Isabel is telling the truth. So therefore, we've got to say that Josh is also innocent and he's telling the truth. So we can take him off the list. Then let's have a look at what Josh has said. Josh has said that Jeniton is guilty. Okay, so if Josh is telling the truth, then surely Jeniton is guilty. But let's have a look what else is being said. We've also said that Isabel is innocent, and Tegan has said Isabel is innocent. So on that assumption, we've got to say that Tegan is telling the truth. So if Josh is saying that Jeniton is guilty, and Jeniton is actually lying, then his statement says that Tegan is guilty, when actually it should say that Tegan is innocent. So therefore that sort of ties in with all our assumptions. So I think we can say that Jeniton is guilty. And that is answer C. Question 14. In the diagram, all the angles marked with a black dot are equal in size to the angle marked X. What is the value of X? We've got answers as A is 100, B is 105, C is 110, D is 115, and E is 120. Okay, so what we've got is we've got a pentagon inside a hexagon. And what we should do is if we label these as two separate shapes, so let's circle the hexagon A and the pentagon B, then what I thought is, well, let's work out what the sum of the interior angles of A and B should be. So, to find the sum of the interior angles of A, we need to work out what the exterior angles are first. So we could do 360 divided by 6, which we know is 60. And then for one interior angle, that's going to be 180 take away 60, which is 120. And then for all 6 angles within the hexagon, it's going to be 120 times 6, which is 720. I'm just going to do the same for B. Also 360 divided by 5, which is 72. 180 take away 72, which is 108. You can do 108 times 5, which is 540. And what we have to consider here is we know that all these black dots are equal to X. For shape A, we've got 6 sides, and 5 out of those 6 sides, the angles are equal to X. So we can say that for shape A, we've got 5 angles that are equal to X, so 5X. Okay, so we don't know what this angle is, so we call this angle Y within the pentagon. But we know that this angle and this angle are opposite angles, so they're going to be equal to each other. So that's why we can also call that Y. So based on that information, we can work out what the interior angle for A is, being that angle that I've just drawn there. And we would label this as 360 minus Y. So we go back to our equation, it's going to be 5x plus 360 minus y is equal to the sum of our interior angles for a hexagon, which is 720. And we can simplify this slightly by saying that 5x minus y is equal to 360. And then we can do the same for b. B's a lot easier because we labelled the 5th angle that we didn't know within the pentagon as y. And we've got 4 other angles that are x. So it's going to be 4x plus y equals 540. And now we've got a pair of simultaneous equations. And they're quite simple because we can solve them by the process of elimination. Because they're both y. And they're different, so we can add them together. The signs are different, so we're going to have 9x is equal to 360 plus 540, which is 900. And therefore, x is 900 divided by 9, which is 100. And that was the question, to find the value of x. So therefore, our answer is A. Question 15. The diagram shows a square PQRS. Points T, U, V and W lie on the edges of the square as shown, such that PT equals 1, QU equals 2, RV equals 3, and SW equals 4. The area of 2UVW is half that of PQRS. What is the length of PQ? You've got answers that A is 5, B is 6, C is 7, D is 8, and E is 9. I've enlarged the diagram here, and we're told that PT is 1, QU is 2, RV is 3, and SW is 4. Now, what we're trying to find is we're trying to find the length of PQ. So as it's a square, it means we're also trying to find the length of RQ, SP, and SR. So if we introduce a variable, let's say X, we can say that's X, and we can say that's X. So of course our area, the area of TUVW is going to be X squared. And then we're told that the area of PQRS is half of that. So the area of PQRS must therefore be a half X squared. Fairly straightforward. But we have been given lengths for SW, VR, UQ and PT. So what are the lengths for these other parts? Well, RU must be X minus 2. TQ must be X minus 1. PW must be X minus 4. And SV must be X minus 3. We can see that we can form an equation. Because what we've got here is we've got 4 right-angled triangles which surround the shape TUVW. So we take the area of the whole shape, which we know is X squared, and then deduct the area of shapes 1, 2, 3 and 4, we can then make that equal to a half X squared. Now, I can already see if I do this, the algebra is going to get quite messy. So what I'm going to do is I'm going to calculate the areas of 1, 2, 3 and 4 separately, and then I'm going to write the equation and then simplify it. So, for shape 1, the area, now we know the area of a right angled triangle is a half base times height. So it's going to be a half times 4 times X minus 3. Which of course is going to simplify to 2x minus 3, which expands to 2x minus 6. Okay, shape 2. It's going to be a half of 3 times x minus 2, which is 3 over 2 bracket x minus 2, which simplifies to 3 over 2x minus 3. Shape 3. It's going to be a half times 2 times x minus 1. That's going to just equal x minus 1. And then shape 4. It's going to be a half times 1 times x minus 4. It's going to be half bracket x minus 4, which simplifies to a half of x minus 2. And now we can write our formula. So the area of PQRS is x squared, so we need to take x squared minus shape 1 is 2x minus 6 minus 3 over 2x minus 3 minus x minus 1 minus a half of x minus 2, and that is all going to be equal to the area of 2UVW, which is a half x squared. We're going to get x squared minus 2x plus 6 minus 3 over 2x plus 3 minus x plus 1 minus a half of x plus 2 equals a half x squared. Okay, so this equation simplifies to x squared minus 5x plus 12 equals a half x squared. Multiply through by 2, we get 2x squared minus 10x plus 24 equals x squared. Subtract x squared from both sides, you get x squared minus 10x plus 24 equals 0. You're left with your quadratic equation. Now 2 factors of 24 are 6 and 4. They also simplify to 10. So our factors are going to be x minus 6 bracket x minus 4. For x equals 6 or x equals 4. So therefore our answer is any one of these. If we substitute x into any of these lengths, it's going to be the total. So the total for PQ is going to be 1 plus x minus 1, which is x. Now x is all dependent on what answers we've got. Now our answers were 6 and 4, so I can't see an option for 4, so the answer must therefore be B is 6. So therefore, answer equals B. Question 16. The diagram shows 2 right-angled triangles inside a square. The perpendicular edges of the larger triangles have lengths 15 and 20. What is the area of the shaded quadrilateral? Answers: A is 142, B is 146, C 150, D 154, and E 158. So let's try and see what information we can get from this diagram. So we know it's a square, so we know that the lengths are going to be equal. So we can say that this length is equal to 20. And we know that the area of that square is therefore going to be 20 times 20, which is 400. Now we're told that we need to find the area of the shaded quadrilateral. So my way of thinking is we know what the area of the square is, and somehow we must be able to determine what the area of these 2 right-angled triangles are going to be. So we take the square, the area of the square, less the area of those 2 triangles should give us the area of that shaded quadrilateral. But of course we don't have enough information to determine what the area of that smaller triangle is. We could work out what the area of this larger triangle is by taking half base times height of 20 and 15. But we need to find out what the opposite and adjacent sides of the smaller triangle are. So what I'm thinking is, because this smaller triangle's hypotenuse is 20, and the larger triangle also has a side of 20, we can take these to be similar triangles. So if we draw out 2 separate triangles. Okay, so I've got the larger triangle and the smaller triangle. The larger triangle has lengths of 20 and 15, and we know that smaller triangle has a hypotenuse of 20. So what we can do is we can find out what the length of the hypotenuse is using Pythagoras for the larger triangle. So we take the square root of 15 squared plus 20 squared. We can get square root of 225 plus 400, which is equal to the square root of 625, which is equal to 25. So we know that the length of the hypotenuse is therefore 25. But how do we find out what the length of the opposite and adjacent sides of the smaller triangle are? If the smaller triangle's hypotenuse is 20 and the larger triangle also has a side of 20, these 2 triangles must be similar. So if I call this side x and this side y, we can work out what the values of x and y are. So x is going to be 20 divided by 25 times by 15. We basically know that the hypotenuse of the smaller triangle is a proportion of the hypotenuse of the larger triangle, so therefore we can work out what the other 2 sides are based on that information. So 20 over 25 simplifies to 4/5 times 15. Now 15 divided by 5 is 3, and 3 times 4 is 12. So we can say x is 12. Now we can do the exact same for side y. Side y is going to be 20 over 25 times 20. And again, that simplifies to 4/5 times 20. And 20 divided by 5 is 4, and 4 times 4 is 16. So y is 16. Okay, so now we can replace this side with 12 and this side with 16. And now all we need to do is work out the area of these 2 triangles. So right, area of a larger triangle. So the area of a larger triangle is going to be a half times 15 times 20, which is going to be 20 divided by 2, which is 10. 10 times 15 is 150. And the area of the smaller triangle is going to be a half times 12 times 16, which is 16 divided by 2 is 8. 8 times 12 is 96. And now we just need to take the area of the square, which is 400, subtract the area of the larger triangle, and then subtract the area of the smaller triangle. And that brings us to a value of 154, which is answer D. Therefore, answer equals D. Question 17. Amy, Beth and Claire each have some sweets. Amy gives 1/3 of her sweets to Beth. Beth gives 1/3 of all the sweets she now has to Claire. Then Claire gives 1/3 of all the sweets she now has to Amy. All the girls end up having the same number of sweets. Claire begins with 40 sweets. How many sweets does Beth originally have? Answers of A equals 20, B equals 30, C equals 40, D equals 50, or E equals 60. They all start off with some sweets. So let's say Amy has A sweets, Beth has B sweets, and Claire has C sweets. Beth gives 1/3 of all the sweets she now has to Claire. So let's say that this is the first scenario. So if Amy gives 1/3 of A away, she's going to have 2/3 of A left. Now, we are told in the question that Claire begins with 40 sweets, so rather than C, we could actually change this to 40. So 1/3 of her sweets go to Beth. So this is going to become B plus 1/3 of A, and then Claire is still going to have 40. Okay, so the second scenario says Beth gives 1/3 of all the sweets she now has to Claire. So what's going to happen is I'm going to have to multiply this expression B plus 1/3 of A by 1/3 to get 1/3 of this result, then subtract that result from this result, and then add it. I'm going to get incredibly messy fractions. So I think let's multiply through by 3 for this first scenario. And then we can do the exact same thing, just everything multiply through by 3. So instead of 2/3 of A, we'll call this 2A. This will be 3B plus A. And then that will be 120. So Beth gives 1/3 of all the sweets she now has to Claire. So that's still going to be 2A. 1/3 of this, well, if I just have a workings column down here, we can say that 1/3 of 3B plus A is equal to B plus 1/3 of A. And of course that gives us 1/3 of B minus 1/3 of A. That simplifies to 2B plus 2/3 of A. And Claire will end up with 120 plus B plus 1/3 of A. Again, we're going to get even more fractions, because what's going to happen is Claire gives 1/3 of all her sweets to Amy, so then we're going to have to do 1/3 of this. I don't want to do that again, so I'm going to multiply the second situation all by 3. So this becomes 6A, this becomes 6B plus 2A, and this becomes 360 plus 3B plus A. Right, and we say Claire gives 1/3 of all her sweets she now has to Amy. So again, we can take 1/3 of this, so 1/3 of 360 plus 3B plus A. That's going to give us 120 plus B plus 1/3 of A. Subtract it from this result. So that becomes 240 plus 2B plus 2/3 of A. that's what Claire ends up with. We'll call this the third scenario. 240 plus 2b plus 2/3 of a. And then Amy ends up with 6a plus 120 plus b plus 1/3 of a. Well, 6 plus 1/3 is 19 over 3a plus b plus 120. So that becomes 19 over 3a plus b plus 120. And then Beth's result is still 6b plus 2a. So what happens now is we are at the end of the third scenario, and we know that they all have the same number of sweets. So all of these three equations are going to be equal to each other now. We've got two unknowns, we've got three equations. So let's take this as equation 1, this is equation 2, and this is equation 3. And first I'm going to make equation 2 equal to equation 3. Equation 2 equal to equation 3. So equation 2 is 6b plus 2a is equal to 240 plus 2b plus 2/3 of a. Okay, so to make life easy, I'm going to multiply 3 by 3. So I get 18b plus 6a equals 720 plus 6b plus 2a. And then subtract my b's from one side, so I get 12b plus 4a equals 720. And then I can divide this equation through by 4. And I'm going to get 3b plus a equals 180, I think that is. Okay, so that is my first equation. 3b plus a equals 180. Now I need to take two different equations. So let's say 1 and 3. Doesn't really matter what equations we take, but yeah, I'm going to say 1 and 3. Okay, so equation 1 was 19 over 3a plus b plus 120 equals 240 plus 2b plus 2/3 of a. Okay, so again, to make life easy, I'm going to multiply through by 3. So that becomes 19a plus 3b plus 360 equals 720 plus 6b plus 2a. Okay, I can then take 2a away from both sides, so I get 17a. I can then make that equal to 360 plus 3b. Okay, and then if I bring my 3b over to the left hand side, I'm going to get 17a minus 3b equals 360. And this becomes my second equation. So now what you'll see, if I put these two equations together, I've got a plus 3b equals 180. And 17a minus 3b equals 360. And eliminate my 3b's by adding the two equations together, so I get 18a 540. I can then get a is equal to 540 divided by 18. 270 over 9, and then of course that simplifies to 30. So we've got our value for a, and then we just need to plug that value into any one of these two equations. So I'm going to go with that first equation we have, 3b plus a equals 180. So if I rearrange that to get b equals 180 minus a over 3. Well, a is 30. So our top line is going to be 150 and then all over 3. So B is going to give us an answer of 50. And therefore our final answer is D. Question 18. The arithmetic mean A of any two positive numbers x and y is defined to be A equals a half of x plus y. And the geometric mean G is defined to be G equals the square root of xy. For two particular values x and y, with x being greater than y, the ratio A to G is equal to 5 to 4. For these values of x and y, what is the ratio of x to y? We've got answers as A is 5 to 4, B is 2 to 1, C is 5 to 2, D is 7 to 2, and E is 4 to 1. So, how I thought about this is we've been given a ratio of A to G is equal to 5 to 4. So therefore we can set each of the equations for A and G to the figures within this ratio. So we'll get 5 equals a half of x plus y. And we can multiply both sides by 2, simplify this and get 10 equals x plus y. Then we can make g equal to 4. So 4 equals the square root of xy. Of course, square both sides, you get 16 equals xy. Now, we could rearrange this so we get x equals 16 over y. And then substitute this equation into our first equation. So we get 10 equal to 16 over y plus y. Well, we've got to have a common bottom fraction. So if we multiply top and bottom by y, we're going to get 10 equal to 16y plus y squared over y. Of course, that simplifies to 16 plus y squared all over y. Bring the y over to the left hand side, you get 10y equals 16 plus y squared. And then bring the 10y over to the right hand side, we get y squared minus 10y plus 16 equals 0. So we've got a quadratic equation which we can factorise to find our two solutions. So two factors are going to be 8 and 2. So make y minus 8 and y minus 2. Y equals 2. And then all we have to do is substitute those y values into the equation x equals 16 over y. So x is going to equal 2 when we substitute 8. And y is going to equal 8 when we substitute 2 in. X is going to equal 8. Now, the question says that for two particular values x and y, with x being greater than y. That means this statement is no longer true under that result, but this one is. So as 8 is greater than 2, we can write the values of x to y in the ratio 8 to 2, and of course this simplifies to the ratio 4 to 1, which is our answer E. So our final answer is E. Question 19. The diagram shows a circle radius 1 touching three sides of a 2x4 rectangle. A diagonal of the rectangle intersects the circle at P and Q as shown. What is the length of the chord PQ? Got answers as A is root 5, B is 4 over root 5, C is root 5 minus 2 over root 5, D as 5 root 5 over 6, or E as 2. I've enlarged the diagram here, and we can show that the side of this length is 2, and the side of this length is 4. And I'm also going to include a point for the centre, and we know that this is length of 1 as it is the radius of the circle. So what we can say is, because the radius is 1, that is directly half of the length of the square. So we can make this into a triangle, so that's length 1, and then if that length's halfway, this length must be halfway, so this length is going to be 2. Now of course we've got a right angle triangle with two sides that we know. So we can find the length from the point of this bottom vertex of the rectangle to point Q. We could do that by using Pythagoras' theorem. So we're going to need to take the square root of 2 squared plus 1 squared. And that is obviously going to give us 4 plus 1, which is root 5. But of course, the length of PQ is going to be root 5 minus a small bit here. But rather than trying to work out what this little bit is, we can do something else. We can take this centre point, and I can draw a line going from the centre to point P, and another line going from the centre to point Q. And because these are both length 1, this would therefore be an isosceles triangle, meaning that these two angles would be the same. And also, because it's an isosceles triangle, I can divide this into 2 right angle triangles. So now we've got quite a small right angle triangle here with an hypotenuse of 1. And we've also got a larger right angle triangle down here with a hypotenuse of root 5. But as you'll notice, the bottom side of this triangle here is parallel to the hypotenuse of the smaller triangle with a hypotenuse of 1. So what we can say is that these triangles are therefore similar. And by using that result, we can work out what this distance of the smaller triangle is. So we can do that by saying that the point CQ is a proportion of the hypotenuse of the larger triangle, so that's going to be 1 over root 5. And then of course this bottom length is 2, so we're going to need to multiply it by 2. So we'll get 2 over root 5 as our adjacent side for the smaller triangle. But we don't want that side, we want the length of PQ. And this is half of PQ. So of course we can just multiply it by 2. It would be 2 root 5 times 2, which is 4 over root 5. And that's the length of PQ. And we've got an answer for that. Our answer is B. Therefore, answer equals B. Question 20. The diagram shows a square PQRS with edges of length 1 and 4 arcs, each of which is a quarter of a circle. Arc TRU has centre P, arc VPW has centre R, arc UV has centre S, and arc WT has centre Q. What is the length of the perimeter of the shaded region? Is it A, 6, B, 2 root 2 minus 1 all multiplied by pi, C as root 2 minus a half all multiplied by pi, D, 2 pi, or E, 3 root 2 minus 2 all multiplied by pi? So let's write down the information that we've been given in the question onto the diagram. So, PQRS is a square with length of sides 1. And we know it's a quarter of a circle, so based on that information, we know that all the interior angles of this square are obviously going to be 360 degrees divided by 4, which is 90. And what needs to happen is, in order to work out the perimeter of this shape, we are going to need to find the arc length of TRU and VPW. So this side and this side, and also the arc lengths of UV and WT. So of course there's a formula from GCSE that you would have learned to find the arc length, which is the angle theta divided by 360 degrees multiplied by 2 pi times the radius. Now, and of course we've worked out the angle, which is 90 degrees, but we don't know what the radius is of this arc, i.e. the length from P to U. But if you have a look at the length P to R, you will see that it's the diagonal of the square. And of course we know the lengths of each side, which are both 1. So what we can do is we can use Pythagoras' theorem to work out the length of PR. So if we say that PR is equal to the square root of 1 squared plus 1 squared, which is equal to root 2. So PR is equal to root 2. So now what we can do is we can substitute these results into this formula, theta divided by 360 degrees times 2 pi r, to work out our arc lengths for TRU and VPW. So we're going to get 90 divided by 360 times 2 root 2 pi. Now 90 over 360 simplifies to a quarter, and obviously 2 divided by 4 is a half, so we're going to get root 2 over 2 pi. So that's nice and straightforward. That is, let's say, the arc length of TRU. But of course that is also the arc length of VPW. So what we can do is we can multiply this result by 2, and both of those arc lengths, it's just going to be a result of root 2 pi. But now we need to find the arc lengths of UV and TW. So how are we going to do that? Well, we know that the radius is obviously equal to the length of PU. This length and PT this length, which are equal to root 2. We need to find this length, say SU, which will be our radius. But we know what the length of PS is, which is 1, and we know what the length of PU is. So we can say that SU must be equal to PU, which is root 2, minus PS, which is 1. So therefore that's also going to be your radius. Your radius is going to be equal to root 2 minus 1. And the same thing here, the angle is going to be 90 degrees because all the arcs are a quarter of a circle. So we just substitute those results into the arc length formula again. So we get 90 over 360 degrees multiplied by 2 pi times the radius of root 2 minus 1. Again, 90 over 360 simplifies to a quarter. Multiplied by 2 pi simplifies to pi by 2. And then, of course, we're left with pi by 2 multiplied by root 2 minus 1. And we'll leave it in that form. And, of course, the arc length of TW is also going to be the same. So to get the total of those two, we can just multiply by 2, which is going to be pi root 2 minus 1. So now that's the total perimeter of TW and UV, and root 2 pi is the total perimeter of TRU and VPW, so we can just add them together. So we're going to have, if we expand this bracket, we're going to get root 2 pi minus pi plus root 2 pi. That, of course, is 2 root 2 pi minus pi. Take out a factor of pi, and you are left with 2 root 2 minus 1, which is answer B. Therefore, our answer was B.